Notes for section 6.1. Starting a new chapter, we will be solving systems of linear equations. So you might recognize the word linear, that we are going to be working with lines, so expect a lot more. Y equals mx plus b, which is what we've been working on in previous chapters. Equations, and the reason why it's called systems is because there are going to be two equations that we're going to try to solve and graph every time. We'll have to find an x and we'll have to find a y. Two equations, two variables. There are three different ways to solve systems of equations. We are going to learn all three different ways, but today we're working on only the first way of solving an equation, a system of equations, and that is graphing. Back to that. It's not going to go away in your math career. We will be graphing. So you should have a handout where you're doing this if possible, so that you don't have to draw all of your own graphs. But let's start with this equation. It's in y equals mx plus b form. This one also is in y equals mx plus b form. So if you're given two equations, you're actually going to be able to find an answer to the question instead, or like solve the equation. We'll come up with an x value and we'll come up with a y value. Before, when we had y equals mx plus b, we graphed it and we were done. Now we have a y equals mx plus b going this way, a y equals mx plus b going this way, and we can find what does x actually equal? What does y actually equal? So let's take that first one. I'll do that one in red. If you have two different color pens or pencils, that might be super helpful to you too. If you can grab a pencil and a pen, or a red, I don't know, blue and a black or something. But we're going to start that first one. Here's our base. Our base is down 7, so we're going to have to go down 1, 2, 3, 4, 5, 6, 7. From there, it looks like we don't have a slope, but we do. 1 over 1, rise over run. So if we go with our rise over run, we have up 1 over 1. And if you want to do it more than once, up 1 over 1, up 1 over 1. So you get a good feel for drawing a very nice straight line. I'm not going to make you use a ruler, but it would actually be super helpful the straighter you make this line, because we're going to try to find where the two lines cross. And if this line goes a little crooked and this line draw it, then you're going to find the wrong spot. So here's going to be my first line. Hey, that was pretty good. Nice and straight. And the second one, I'll do that one in blue. Here's our base at -2, down 2. And our slope is -1/4. Remember, when we have negative numbers for slopes, we can choose which way we want to go. Do we want to go down 1 and to the right 4, or do we want to go up 1 and to the left 4? Now, I know I've talked to you about that you can't actually put a negative in the denominator, not when you have your final answer, you put it out here. But if you're just showing your work, either one of those is fine. But we're going to check and see if we know that these have to cross. Are we going to go down 1 over 4 or up 1 left 4? We want to run into this red line. We want to make sure we get there. So we for sure don't want to go up 1 and left 4, because that takes us in the wrong direction. So we're instead going to go down 1 and to the right 4. And check that out. They perfectly cross right on top of each other. That one wasn't quite as straight, but I was able to hit right on the line. If you're looking for straighter lines, I probably should have made another dot. Down 1 over 4, and then that gives me more of a target of how to make a straight line. See, I dropped off again. We'll just stop it there. Okay, so now you've got your two lines graphed. How does that help us? It's actually asking us, where is x, where is y, where do they work for both equations? We're going to take this spot right here, the intersection of the 2 points. If you need to circle it or do something so that you know what you're looking for, go back to the origin and find the coordinates of this. We went over 1, 2, 3, 4. And then we went down 1, 2, 3. So the answer to solving that system of equations is x equals 4, y equals -3. Of course, we write it like this because it represents our graph, that you have a point on the graph, a coordinate. Now, check this out. I'm going to grab my calculator. On here, remember my answer is 4, -3. I'm going to plug into this first equation. I know that my x is 4. I want my y to be -3. Let's see if that works. 4 minus 7, some of you could do this in your head, I hope, is -3. So it works on that equation, but we also have to check it over here on this equation. So let's try that. -1 fraction 4 times 4 minus 2. You write in that whole equation. With the 4 substituted in, it equals -3. What was it supposed to equal? -3. If it works in both equations, you know that you did it right. There's going to be more examples of this, but nothing really new. You've graphed before. It's just that now you have to graph 2 lines at the same time and come up with a coordinate for the answer. Make sure you're counting carefully. The x always comes first and then the y. And then there will be some equations that they're not in y equals mx plus b form. So let's take a look at a few of those. Y equals 5x. Y equals -5x plus 10. Friendly reminder, there's not a b listed there, but that doesn't mean it doesn't exist. We have a base of 0. I'll do this blue line first. From there, our slope is 5. Up 5. Nope. Rise over run. If there isn't a run, put it over 1. Up 5, over 1. And you may want to do it a couple of times again so you make a nice straight line. Okay, I'll draw my line through here. Switch to the other side. Switch colors if you can. We're going to start up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then go down 5 and make sure you go +1. Down 5, right 1. 1, 2, 3, 4, 5. Hey, check that out. They match. And if they don't, for today, for the introduction, if they don't meet up at a point, then you made a mistake somewhere. Go back and double check your negatives or your slope. Rise over run. There they go. We found a point where they intersect. We have to count it as x and y. Go back to your origin and count from there. X went to the right 1 space and up 1, 2, 3, 4, 5. We'll check one more of these, but then I won't take the time to do it every time. -5 times 1 plus 10. -5 times 1 plus 10 equals 5. 5 times 1 equals 5. Next one. Up 3. 1, 2, 3. Up 1 over 2. And I know I'm kind of cruising through these a little bit fast, but that's because we've been graphing for a long time. Pause it or rewind it or slow it down if you have to. Up 1 over 2. Up 1 over 2. I'm going to do enough to make a nice straight line again. Red line, down 2. And then we're going to go, we're going to go down 2 over 1. Down 2, right 1. If I go down 2 and to the right 1, I'm going to keep getting further and further away from the blue line. So I'm going to have to switch it up, move my negative, and instead go up 2 and left 1. Put the negative in the denominator. Up 2 and left 1. Uh-oh. No, it's really not good. Did I make a mistake? Up 1 over 2, up 1 over 2. Yes, I did make a mistake. Why didn't you tell me? We were supposed to start down 2 and then go down 2 over 1. Let's get back to where we started. Here's the origin, down 2, and then down 2 over 1. But we still do need to switch it to up 2, left 1. So we're going to go up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. Now, apparently I missed, and I was a little bit short on the blue line. So even the blue line has to change its slope. This blue line, we went up 1 over 2. Well, this has been drilled upon you in the last few months of algebra that 2 negatives make a positive. Go ahead and make them 2 negatives, as long as it's in your work. From here, go down 1, right 2. Down 1, right 2. And of course, now your 2 lines cross. So depending on where the lines are, you may have to switch up your negatives on your slope. Final answer of this one, find an x and find a y. Go back to the origin. The x went left 2 spaces, and the y went up 2 spaces. Negative 2, 2, and of course we could plug it back in and check our answer. Okay, this one, a little bit extra work to do on this because the first problem is in y equals mx plus b form. I'm going to start down 5, and then from there I'm going to go up 1 over 1. So down 5, 1, 2, 3, 4, 5, up 1 over 1. And of course I'm going to want to do more than that because that's a tiny little, I'm going to keep going. And maybe we might have to go this way. You could do them that direction right away. Over here, though, we are not in y equals mx plus b form. I'm going to put it in y equals mx plus b form. And we're going to go green. Minus 3x from both sides. Get rid of that. Y equals negative 3x plus 3. How do we graph that? Up 3. Go down 3, right 1. Down 3, right 1. Till you run into the other graph. Go ahead and draw it past. Show that it's a full line. Ooh, that was another pretty straight one by me. Find your answer right here on the graph. Answered is x, 1, 2. Y, down 1, 2, 3. We've got 3 of those left. What if this happens? We'll graph it up 5. Nope, down 5 because it's negative. 1, 2, 3, 4, 5. That's our base, our y-intercept. From there we're going up 2 over 1. So if we go up 2 over 1, do it a few different times, or down 2 left 1. Depending on which direction we think we're going to have to go. Then I'll graph the red line over here. I'm going to add 2x to this side. And I have y equals 2x plus 3. If you were paying attention in chapter 4, I think you might already know what's going to happen here when you look at your slopes. I'm going to start this one up 3. And then I'm going to go up 2 over 1. And these 2 lines have the same slope. I can go down 2, left 1, try to run in this other line. When am I ever going to run into this other line? Absolutely never. We've got 2 perfectly parallel lines. What happens if you have the same slope and a different intercept? This one started up 3, this one started down 5. It wants to know when are y and x going to solve this problem? They're not. There is no solution to this problem ever. No solution. And please, when you answer this, you have to put no solution. That's the answer to the question. Where do these systems of equations, where do these lines meet? There is no solution to it. You can't say undefined, because undefined would mean that we're dividing by 0 and we have a vertical line. That's not what we're working with. We just have 2 lines that never touch. No solution. Here's another what if. First line is all set and ready for us. We're going to start up 3 and then go up 2 over 1 or down 1 over 2 or down 2 over 1. Either up 2 over 1 or down 2 left 1. Draw your line. This one, of course, is not in y equals mx plus b form. It looks like we've got a 2-stepper this time. I'm going to add 4x to both sides. You get 2y equals 4x plus 6. Divide by 2, divide by 2, divide by 2. y equals 2x plus 3. That looks familiar. Up 3. Up 2 over 1. Up 2 over 1. Down 2 left 1. That's exactly the opposite of no solution. Instead of saying, no, they're never going to touch, we don't have a solution, now you're saying they're touching all the time. Everything is a solution to this problem. It all works no matter what, which means we have an infinite solution. You can draw the infinity sign to say infinite solution, or you can write infinite solution, meaning pick an x and a y on this line and it's going to work. And I'm going to show you that quick because we said if 2 points intersect, that's the answer. So I'm going to pick that point. It's over 1, up 1, 2, 3, 4, 5. If I plug in a 1, 2 times 1 is 2, 2 plus 3 is 5. Well, if I plug it in over here, 2 times 1 is 2, 2 plus 3 is 5. Of course, whichever equation you plug it in, you're going to get the same answer because it's the same equation. I could have picked this point, 0, 3. Plug in 0. 2 times 0 plus 3. 2 times 0 plus 3 is 3. I could have picked this point, negative 1, 1. But instead of picking a whole bunch of different points, we just say it's an infinite solution. They're all going to work. So you got to know the difference in the terminology between when to use no solution and infinite solution. And your favorite. We have horizontal lines and vertical lines again. Seems to me it's always a quick guess, like, oh, I got a 50-50 chance of drawing it the right way, instead of think your way through this. What does this actually mean? This tells you that y is 5. And most of you, 1, 2, 3, 4, 5, go up and draw your point, y is 5. And you have no problem with that because you know where y is. And then I watch you draw a straight up and down line. Well, that means y is 6 and 7 and 8 and 9 and 10. Y can only be 5. The only possible solution you can have for this equation is that y is 5. So if I pick this point right here, you don't have to write this down, but this point is left 1, 2, 3, 4, 5, and up 5. This point is left 3, up 5. This point is right 3, up 5. This point is 8, 5. So you gotta just kind of, instead of guessing your horizontal and vertical lines, know that if y equals 5, every single point on that whole line has to have a y of 5. Another way people do it is do y equals mx plus b. If y equals 0x plus b, which would be 0x plus 5, you start up 5, make your slope of rise over run, up 0, meaning you can't move, over 1, up 0, over 1, up 0, over 1. That one you can put in y equals mx plus b form. This one you can't. So you got to do the thinking instead. Say x equals 2. Here's x, here's 2. You want the x to always equal 2. Every single point on this line has an x of 2, and the y changes. What is the final answer to this solution? Of course, it's over 2, up 5. Hello. X has to be 2, y has to be 5. That's the only solution you can come up with, but you have to have a graph to support it. X is 2, y is 5. That's where they meet. All right, you should be able to do this work assignment on a worksheet because then you have graphs with it. Watch your negatives, watch your slopes, rise over run, y equals mx plus b. Good luck.